We'll be looking at 3a, Pythagoras' theorem. So the key ideas for today is that the longest side of a right-angled triangle is called the hypotenuse, and this is always opposite the right angle. So the theorem of Pythagoras says that the square of a length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. So we're given this formula here, c squared equals to a squared plus b squared. Now, c is going to represent the square of the hypotenuse, whereas a squared and b squared are going to represent the squares of the two shorter sides. So on this triangle here, we have a length of a, we have a length of b, and you will notice the hypotenuse, which is the longest side opposite the right angle, which is here, is going to be labeled c. So this theorem can be illustrated in a diagram like the one on the right. The sum of the areas of the two smaller squares, a squared and b squared, is actually the same as the area of the largest square, which is c squared. Now if we look at this second dot point, lengths can be expressed with the exact values using surds. So the root of 2, root of 28, and 2 root 3. These are all examples of surds. If we look at this diagram here, if I illustrate three squares in this case, so one has an area of a squared, one has an area of b squared, and one has an area of c squared. If I chop these squares up, what you'll notice is we get one giant square that's made of the blue and the green square, which is equal to the area of the square that is c. So let's try a couple of these examples ourselves. Find the length of the hypotenuse in these right-angled triangles. Round to two decimal places in part B. So to work this one out, for part A, if I'm trying to find the hypotenuse, you guys will remember the formula is a squared plus b squared equals c squared. A we can label as 3, b we can label as 4, and c will leave it as unknown. So we've got a, which is 3 squared, b is going to be 4 squared, and c will just leave it as it is. 3 squared will give me 9, 4 squared will give me 16, equals to c squared. 9 and 16 will give me 25, equals to c squared. And we can just find the square root of 25, which is going to give me c. So c equals to 5. So for example B, we do the same thing. We can label 5 as a, and we can label 2.5 as b. So once again, a squared plus b squared equals c squared. A will be 5 squared, b will be 2.5 squared, and c squared will leave as is. 5 squared will give me 25. 2.5 squared will give me 6.25 equals to c squared. 25 plus 6.25 will give me 31.25 equals to c squared. Square root of 31.25 to get rid of the square, and that will give me c. So if you put this into your calculator, you should get 5.59. Find the length of the hypotenuse in this right-angled triangle, leaving your answer as an exact value. So an exact value means we don't want the decimal. Alright, once again, label A, B, and C. So we'll say 3 is A, we'll say 7 is B, C will leave as is. Once again, A squared plus B squared equals C squared. A squared will be 3 squared, B squared will be 7 squared, and C squared will leave as unknown. 3 squared gives me 9, 7 squared gives me 49, equals to C squared. 9 plus 49 will give me 58, equals to C squared. The square root of 58 will give me C. So that's it for this one. Hopefully you learned something. I'll see you on the next one.